Hello, this is Sujit. Welcome to Physics 2020. So today we are going to discuss the last topic, that is relative velocity in the chapter motion in a straight line. So in this chapter, that is motion in a straight line, we have discussed a variety of topics starting from distance, displacement, velocity, acceleration, the kinematic equations of motion, motion under gravity, and the graphical analysis of motion. So for each and every topic we have discussed the conceptual video as well as the problem solving video. So in this video we are going to discuss the concepts of relative motion, relative velocity. In the coming video, in the coming session, we will discuss the problems related to relative velocity. So in our channel, that is Physics 2020, there is a playlist called that is mathematical support for physics. So in that playlist I have posted 4 videos. The first video, that is the trigonometry, second and third video, that is differentiation, and the fourth video, that is integration. Okay, so after completing this chapter, that is motion in a straight line, with the problem section of relative velocity, I will start the second chapter, that is motion in a plane or motion in 2 dimensions. So my dear students, this relative velocity is a very important topic. You can expect a variety of questions from this topic for Neet as well as JEE examinations. And the relative velocity, that is in the next chapter, motion in a plane, that is motion in 2 dimensions, there is a velocity, that is relative velocity in 2 dimensions. So in that relative velocity in 2 dimensions, we will solve a variety of problems like Rainman problem, boat river problem. Okay, so the variety of problems we are going to discuss. So if you want to clearly understand the relative velocity, the topic relative velocity, first understand the relative velocity in 1 dimension, then only you can easily understand the relative velocity in 2 dimensions. Okay, fine. So we are going to start with relative velocity. Relative velocity. So my dear students, before starting with that is relative velocity, I think we can start with that is relative motion. Relative motion. Okay? Relative motion. So while traveling in the train, you might have experienced that is relative motion. So you are sitting in a moving train and watch outside. If you are watching through the window outside, you find that the train in the other track, which is at rest, seems to be moving. Okay, so the train in the other track, which is at rest or stationary, seems to be moving in the backward direction. So why the objects? That is for the observer, that is the train is moving, that is seems to move in the backward direction for you. For the observer who is sitting in the platform, that is seems to be rest. Okay, the train is at rest. So but for the passenger sitting inside the train seems to be moving. So how does the train seems to move? How does the train which is at rest seems to move? So behind that it is the beautiful concept or very important concept, that is called relative motion. That is called relative motion. So relative motion makes us to understand how the objects move differently in different frames. Okay, so relative velocity makes us to understand how the objects move differently in different frames. Different frames. So this word is very important, that is frames. So we will use that is frames or frame of reference or reference frame. Okay, reference reference frame. So before studying that is, or if you are studying the relative motion, you have to clearly know about this frame of reference or reference frame. This reference frame plays a vital role in relative motion. So what is meant by frame of reference? Frame of reference is nothing but the location at which the observer is situated. Okay? So the relative frame of reference is nothing but the location at which the observer is situated. So in relative motion, the place at which the observer is situated is very, very important. Okay, so far that is, we have studied the motion, we didn't specify the position of the observer. So in relative motion, we have to clearly say that where the observer is situated. So that is the definition. Reference frame is the location at which the observer is situated. So otherwise we can say that reference frame is the location with respect to which all the measurements are taken. Okay, so that is reference frame. So in short form, you have to keep in mind the reference frame is the place of the observer. For example, an observer is on the ground. Okay, if an observer is standing on the ground, so ground is the frame of reference. Okay, ground is the frame of reference. If an observer is on the train, okay, if an observer is on the train is the frame of reference. If an observer is on the aeroplane, so the frame of reference is aeroplane is the frame of reference. Okay, aeroplane is the frame of reference. Okay, so that is relative motion. Relative motion means the relative motion so gives the idea how the objects moves differently in different frames. That is relative motion. What is a frame? That is frame of reference. Frame of reference. It is the location at which the observer is situated. So if the observer is on the ground is the frame of reference. If the observer is on the train is the frame of reference. If the observer is on the aeroplane is the frame of reference. Okay. So suppose a body is moving with the velocity. So moving with the velocity that is 10 meter per second. Okay, 10 meter per second. So this velocity belongs to some frame of reference. Okay, this velocity belongs to some frame of reference. Normally ground or earth. Okay, normally ground or earth is considered as the frame of reference. Okay, normally ground or earth is considered as the frame of reference for every motion. Okay, suppose a body is moving with 10 meter per second means, what is the meaning? That velocity is with respect to some frame of reference. Okay, frame of reference. Normally, so what is the frame of reference? We consider ground or earth as the frame of reference. Okay, frame of reference. For example, a passenger is moving in the train. Okay, passenger is moving in the train. So the train is moving with that is 60 kilometer per hour. Okay, 60 kilometer per hour. So a person who is standing in the platform, so watching the train, so he is watching the train. So he feels that, so the passenger is moving with 60 kilometer per hour. Am I right? So now the frame of reference is ground. So because the observer is standing on the platform, standing on the earth. Okay, so ground or earth is the frame of reference. A passenger is sitting inside the train is moving with 60 kilometer per hour, and a person who is standing on the platform is watching the train. So he feels that the passenger is moving with 60 kilometer per hour. Suppose the observer gets into the train, and he is sitting with the passenger, and he observes the passenger. So what is the speed of the passenger? That is 0. That is, he feels that the passenger is at rest. So that is, in the initial first case, the frame of reference is ground. So he feels that the passenger is moving with 60 km per hour. So now he changes the frame of reference from ground to train. from ground to train. So the second frame of reference, that is he is inside the train and watching the motion of the passenger. So he feels that the passenger is at rest. Passenger is at rest. So when we changes the frame of reference to frame of reference from ground to earth, he feels that the passenger is at rest. So that is the role of frame of reference. So if we study, in short form, that is if we study the motion of the object with respect to the frame of reference, then it is called relative motion. It is not motion, it is called relative motion. So if you study the motion of the objects with respect to a frame of reference with the help of frame of reference, then it is called relative motion. Okay? So the next is relative velocity. Relative velocity. So we have discussed what is a relative motion. So next we are going to discuss relative velocity. Relative velocity of one object is one object with respect to another object. Okay. So relative velocity is nothing but the velocity of one object with respect to another object. That is, suppose two bodies A, which is moving with velocity, that is Va. Another object B, which is moving with velocity, that is Vb. Okay, Vb. So the relative velocity of A with respect to B, that is, we will use the notation, that is V A B. Okay, V A B. That is relative velocity of A with respect to B. So similarly, relative velocity of B with respect to A, that is V B. Okay, we will use the notation V B. So how to find out the relative velocity? Suppose the body is moving with the velocity Va and another body is moving with the velocity Vb. So how to find out the relative velocity, or what is the expression for, or what is the formula for finding the relative velocity? Okay, relative velocity. So that we are going to derive. Okay. So consider two frames. That is, this is a S dash frame, okay. So X dash, O dash, Y dash, okay. So consider another frame. That is S frame, okay, S frame. So X, O, Y, okay. So the motion of a particle, okay, consider a particle, motion of the particle P, okay, P is observed from these two frames. The motion of the particle P is observed from these two frames, that is S dash frame and S frame. These frames are also moving with respect to each other, okay, So the position vector of the particle P with respect to the frame S Okay. The position vector of the particle P with respect to the frame S is, that is OP. Okay, OP. The position vector of the particle P with respect to the frame S dash is, that is O dash P. Okay. So the position, similarly, the position vector of the frame S dash with respect to the frame S is, that is O dash. Okay, O dash. O dash. Okay. So the position vector of the particle with respect to the frame S is, that is OP vector. The position vector of the particle P with respect to the frame S dash is O dash P vector. The position vector of the frame F dash with respect to the frame S is, that is O dash. So we can write position vector. Okay, position vector of P with respect to S. Okay, that is, we can write R P S vector is equal to, that is OP vector. OP vector. Okay. So similarly, position vector of P with respect to S dash, that is, we can write R P with respect to S dash vector is equal to, that is O dash P vector. Okay. So similarly, position vector of S dash frame. Okay, S dash frame with respect to S, that is, we can write R F dash with respect to S is equal to, that is O dash vector. O dash vector. Okay. So the position vector of P, the position vector of P with respect to S, the position vector of P with respect to S dash, and the position vector of S dash with respect to S. So from this diagram we can write, that is OP vector. Am I right? OP vector is equal to O dash vector plus O dash P vector. Okay, P vector. From the diagram we can write OP vector is equal to O dash vector plus O dash P vector. So what is OP vector? That is R PS vector is equal to O dash vector, that is R F dash S vector plus O dash P vector, that is R P S dash vector. Okay, vector. So differentiate with respect to time. Differentiate with respect to time. Take it as equation number 1. Okay. Differentiate equation number 1 with respect to time. Okay, with respect to time. So d by dt of R PS vector is equal to d by dt of R S dash S vector plus d by dt of R PS dash vector. So this equation I am differentiating with respect to time. So d by dt of R PS vector is equal to d by dt of R S dash S vector plus d by dt of rp f dash vector. Okay. So the differentiation of the position vector, that is position with respect to time, gives the velocity. Okay, so velocity v p s vector is equal to d by dt of rs dash, that is v f dash s vector, plus d by dt of rps, that is v p f dash vector. Okay, dash vector. So here v ps vector is equal to velocity of the particle with respect to the frame s. V f dash s equal to the velocity of the frame f dash with respect to s. V p f dash vector is equal to velocity of the particle with respect to the s dash frame. Okay, s dash frame. So from this I am writing v p s dash, okay, s dash vector is equal to, that is v ps vector minus v f dash s vector. So from this what we can conclude? So if you know the velocity of two objects, here the velocity of p and the velocity of the frame s dash, okay, with respect to a common frame, yes, with respect to a common frame, yes. So understand well, listen. So if you know the velocity of two objects with respect to a common frame, here in our case, so the velocity of the particle p and the velocity of the frame s dash with respect to a common frame, yes, okay, with respect to a common frame, yes. So we can find the velocity of one object with respect to another object. So we can find the velocity of the particle with respect to s dash is equal to velocity of the particle with respect to the common frame s minus velocity of s dash with respect to the common frame s. Okay, so now come to our case, that is, so two objects, that is a object which is moving with the velocity va and object b is moving with velocity vb, okay, vb with respect to a common frame, okay, with respect to a common frame, that is ground, with respect to a common frame, ground. So a and b are moving with the velocity va and vb with respect to a common frame. So more accurately writing means, that is v a. So how to write? That is v a g, that is velocity of a with respect to ground. So more accurately writing, that is v b g with respect to a common ground means. So two objects moving with the velocity certain velocity with respect to a common frame ground means common frame. So we can find the velocity of one object with respect to another object. That is how we can write, that is v AB is equal to from this expression, that is velocity of P f dash, common frame P f dash is equal to velocity of P with respect to common frame. So velocity of A G minus velocity of B G. So this gives the relative velocity of A with respect to velocity of A with respect to B. So from this expression we are writing. So if you know the velocity of two objects with respect to a common frame, then we can find the velocity of one object with respect to another object. So VAG is the velocity, VB is the velocity with respect to a common frame ground. Then we can find the velocity of the one object with respect to another object. That gives the relative velocity. So VAB gives the relative velocity of A with respect to B. So that is VAG minus VBG. Okay. So in short form we write that is VAB is equal to, that is VA minus VB. Relative velocity, we will write the expression like this in short form. That means it is understood that is the common frame is ground. If the frame of reference is not specified, means that is the frame of reference is ground only. Okay. So VAB is equal to VA minus VB. Clear? So understand the formula for our expression or formula for finding the relative velocity means VAB is equal to VA minus VB. So similarly the velocity of B with respect to A is equal to, that is VB minus VA. Okay, VB minus VA. ठीक है. So the relative velocity BA vector is equal to BB vector minus VA vector. Okay. So case 1, the two objects are moving in the same direction. Okay, moving along the straight line in the same direction. So this object A is moving with velocity, that is VA, and another object B is moving with velocity VB. Okay, so the relative velocity of B with respect to A vector is equal to VB vector minus. So velocity is a vector quantity. The objects moving in the right direction is taken as positive. Okay, right direction. In this direction, rightward direction is taken as positive, and the object moving in the leftward direction is taken as negative, because velocity is a vector quantity. Okay, so VB vector minus VA vector, because both the objects are moving in the rightward direction. Okay, so if VBA vector is positive, it is positive. Positive means what is the meaning? So velocity of B with respect to A, because this is the observer. Okay, this is the observer is in object A. So that means it is at rest. Okay, it is at rest. So object B is moving. So it is a positive, means it seems that B is moving away from A. B is moving away from A. Okay. So similarly, if BA vector is negative, so the relative velocity BA is negative, means so the object, that is velocity of B with respect to A, that is the observer is on object A, that means it is at rest. So BA is negative, means it is in the opposite direction, it is coming in the leftward direction. That means the observer seen in the, what is the feeling, that is the observer is sitting on the object A and is watching through B. Okay, watching through B. So it approaches that, it feels that B is approaching to A. B is approaching to A. Okay, so B is approaching to A. So VBA, that is, if we get the relative velocity of B with respect to A, if we get the negative quantity means the observer sitting on the object A feels that B is approaching to A. So if it is positive means B is going away from A. Okay. Then case 2. Case 2. So the two objects are moving along the straight line in the opposite direction. Okay. That is A, which is moving with velocity VA, and object B, which is moving with velocity, that is VB. Okay, VB. So the relative velocity of B with respect to A vector is equal to VB. Okay, VB minus, that is the formula, VB minus VA. So here the VB is moving in the leftward direction, so it is negative. VB minus, it is in the rightward direction, so VA. So that's equal to minus of VB plus VA, minus of VB plus VA. So this quantity, whether velocity of B with respect to A, okay, velocity of B with respect to A. So A is the observer, that is at rest. So anytime that is, it is a negative only, okay, negative only. So it always approaches, B is approaches to A, that is negative direction. So the relative velocity is negative. VBA is negative. That is the velocity of B with respect to A. That is the velocity. It is always negative quantity. Okay, negative quantity. So that means, so the observer is sitting on A and he is watching the B. So it always approaches to A. Okay, negative means B is always approaches to A. Okay. Then case 3. Case 3. So the two objects are moving along the straight line. It is A. So it is moving, along the straight line and moving away from each other. Okay, away from each other. So it is moving with velocity VA, and this object B, which is moving with velocity VB. Okay, VB. Okay. So the relative velocity VBA vector is equal to VB minus VA. So that's equal to, that is a formula. So here VB is moving in the rightward direction, so positive. So positively, that is VB vector minus of, so VA is moving in the leftward direction, so minus of VA vector. Okay, so that's equal to VB vector plus VA vector. So the relative velocity of B with respect to A, that means A is the observer. Okay, A is the observer. So A is at rest and observer is sitting on A and B is watching. So here we are getting that if VBA is equal to VB plus VA, that is, it is always positive. That means B is always moving away from A. B is the observer sitting on the object A feels that B is always moving away from A. So that is because it is always positive. Okay. So these are the different cases of relative velocity. So we have discussed what is relative motion, what is relative motion, what is relative velocity. So how to find how to derive the expression for relative velocity, okay, using the help of different frames of reference and particle motion. So we have derived the formula, that is for relative velocity Vb minus Va. Okay, so then different cases also we have discussed. So in the next video we will come with the variety of problems of relative velocity. Okay, so we will discuss the problems. I think I would like to include 10 problems in this section, that is relative velocity, in the next section, next video. So stay tuned. Bye.